just going to repeat some of the examples the books showed us. 2x over x minus 1, that's a rational expression. Y minus 1 over y squared plus 4. X squared minus x over x squared minus 5x plus 6. So what makes these rational expressions? Well, they have a polynomial in the denominator. They do not have a radical in the denominator. This is kind of a different category that we're going to look at those kinds of expressions, but that's not what we're talking about right now. Okay? So, we have here some variables, and one of the things we're concerned with is what is the set of values, and we're talking about real numbers. What set of the real numbers can we plug in here? Or what is the set that we want to plug in? So typically, we start with the assumption that we'd like to plug in all of the real numbers. That's going to work fine here. We can plug in any real number for y we want. Things are fine. But as you can see in this expression, 2x over x minus 1, we're going to have a problem. What's our problem? Yeah, we can't put in 1. So we're going to define a term, the domain. In this case, specifically the domain of a rational expression, as that set which we're able to and willing to plug into an expression. So here, our domain is x such that x is a member of the reals, but x is not equal to 1. Okay, that's a set. We could graph that online. We kind of look a little simple, but there's 1, a little hole there, and it's all the reals except that one. This expression, of course, the domain is all real numbers. This one, it's not really obvious, is it? We have to do a little work, right? We have to try and factor this, don't we? All right, let's take a look. We don't need to factor the numerator, but I'm going to do that anyway. Okay, this looks like x. That looks like a nice, I think I put this up on the board yesterday too, right? This looks like a nice easy FOIL, doesn't it? Inners minus 2, outers minus 3, that's minus 5. Minus 2 times minus 3, 6, good. Okay, so the domain here is x such that x is real, but x is not equal to 2, and x is not equal to 3. So this is the domain of a rational expression. We're going to talk about domains in other contexts. If I said, this is not a rational expression, but if I said, what's the domain of square root x? Do you have any thoughts on that? Yeah, that would be x greater than or equal to 0, because if I put in a negative number, it's not real, it's imaginary. Okay. want to say that when we talk about some expression, like, take this one again, we could actually have some smaller set in mind. We could actually have a domain we could just be interested in, say, okay, does that work as a domain? Is there anything in this from 0 to 1 that we can't plug in here? I don't think so. I think we're good. But usually, you'll see a question, what is the domain of this function? And what they mean is, well, starting with all the reals, what are the values that we can plug in? The assumption is we don't specify some smaller domain or some smaller set that we want to look at. We're always looking at the biggest possible set. Okay. All right. Questions on domains? Yes.
Just like the X.
Love it when students are paying attention. Thank you. Yeah, I say it not, but my right hand sometimes doesn't listen to what my head is saying. Exactly. Thank you. Okay. All right. Next thing we want to look at is how to simplify a rational expression. So if we have symbolically here AC over BC, where A and B and C polynomials, and C is not 0. I guess I want to put that somewhere else. C is not equal to 0, then this is equal to AB. Looks like I'm just doing something with a fraction here, but we're talking about polynomials. So, for example, if I have x squared minus 1, x squared plus x minus 2, well, first I'm going to have to factor these to see if I can simplify it. So, x squared minus 1, of course, is x plus 1. That's x minus 1, that's our a squared minus b squared pattern. This guy I'm going to have to try to reverse FOIL. X 2, 1. Okay. So if I have a plus here and a minus here, right? The outer is plus 2x and the inner is minus 1x. That gives me my x. So that works. Okay, so now here's the c in my expression. It's x minus 1. So I can say that I can simplify this. This is x plus 1 over x plus 2. When you simplify an expression like this, you want to be very careful, because the domain has not changed. Here the domain is, I'm going to leave out the real part for now. This is just x not equal to 1 and x not equal to minus 2. Well, here you only see the x plus 2 in the divisor. But you still cannot use 1 or minus 2. That's because while we've simplified this, the original expression would still be undefined if x were 1. You're still dividing by 0. Just because you're multiplying by 0 and dividing by 0, you can't cancel that. That's why this c not equal to 0 is so important. Okay, that's simplifying. Along the same lines, if I want to multiply two rational expressions, again, a, b, c, d here are polynomials. I'm going to stop for a second. Yes, question?
Yeah, for the domain of the other one, is it x equals -2 or x doesn't equal -2?
I did it again. Thank you. Another observant student. Thank you. I appreciate when you point that out because, you know, there are other students who are going, didn't he mean that? Yeah. Yes. Okay. Multiplying. Okay. Oh, I wanted to ask, is everybody like comfortable with odd as multiplication? Right? Sometimes you use a cross multiplication sign, and of course, if we just write AC, we get multiplication 2. It's a notation thing. I hope everybody should be familiar with that. Okay, so A over B times C over D. We're talking about polynomials, but it's just A, C, B, D. Here's an example. We have x squared plus 2x minus 3 times 3x plus 12. Should write the whole thing out, shouldn't I? Okay, so I have this rational expression over here. I'm multiplying it by this one. Well, I should try and simplify this, which again means I'm going to have to do some factoring. So let's look at this first. X squared plus 2x minus 3. Reverse FOIL, although it's kind of awkward at times, it comes in handy. I wouldn't want to stop here and start running through the quadratic formula. Okay, so it's minus, so there's 1 minus and 1 plus. Plus obviously goes here. 3x minus 1x is 2x. All right. Let's look at this guy. He's really easy. Why is he really easy? Hint. It's a pattern we look at. This is like a squared, and this is b squared. Right? So b is 4 and a is x. And 2ab is ax. So this is just x plus 4 squared, and I'm going to write it out. I want to start honing in on those patterns because they're going to make things simple in the future. Okay, here I have a factor I can just multiply here. This is 3x plus 4. And we have x minus 1 below. Okay, so there's some canceling we can do here. X minus 1, x plus 4. So simplify, this is x plus 3 over x plus 4. Again, with the caveat that the domain of this has not changed from this. And what are the bad values in the domain that we don't want in the domain here? Minus 4 and 1. You won't see that here, but you'll have to keep that in mind. Okay, first question.
What about the 3 next to the x plus 4? It's like 3 times x plus 4.
Now you've got it, right? You got to watch the professor. He sometimes is thinking about the wrong thing. Thank you. Other question? Was it the same question?
Mhm.
Yeah, okay. Okay. All right, that's multiplying rational expressions. We can multiply them. We can divide them. So just like with regular fractions, instead of dividing, we can multiply by the reciprocal. So, as an example, let's take x minus 4, or x squared minus 4, divided by x squared minus 3x minus 4, over x squared plus 5x plus 6. Well, the first thing we want to do here is, instead of dividing, we want to multiply by the reciprocal. So, x minus 4, x squared minus 4, times x squared plus 5x plus 6, over x squared minus 3x minus 4. The reciprocal of this expression. And now we have to go through our step of factoring. So this is x minus 4. What do we have here? Well, two times 3 is 6. 2x plus 3x is 5x, okay? X squared minus 4, that's a pattern, right? X plus 2 times x minus 2. And now we have to reverse FOIL this. These problems are set up to work this way. You might find the problem somewhere in the real world or in your homework where FOIL doesn't work. That can happen. Okay, we've got 4 and 1, and we need a minus 4 and a plus 1. Okay. Right away, we can see that the domain here excludes minus 2, 2, minus 1, and 4. And that's not going to change. But in simplifying this, we can get rid of the x minus 4, get rid of the x plus 2. And so, intruding over here, right, equals x plus 3 or x minus 2 times x plus 1. And if it suits the problem, you can FOIL this, but leaving something like this is fine. Okay. Right. Now we come upon that oddity of fractions where, while adding, everyone thinks that adding is, subtracting is easier than multiplying, dividing. But adding fractions is a little harder, right? Because you need a common denominator. The same thing holds with rational expressions. I want to add two rational expressions. Well, now I need a common denominator. So the common denominator here is going to be x minus 1 times x plus 2. So let me convert each one of these. To convert this to x minus 1 times x plus 2, so you have to multiply the bottom by x plus 2, but of course I have to multiply by 1. X plus 2 over x plus 2 is 1. And I'm going to add that to x over x plus 2 times x minus 1 over x minus 1. Right? On the top, we have 3x plus 6. And over here I have x squared minus x. And we'll just leave this x minus 1 times x plus 2 for now. Let's collect like terms here. We have x squared minus 2x plus 2x plus 6. Again, over x minus 1 times x plus 2. Maybe we can factor this. I'm not sure. Let's try. Okay, so here's one of those trickier ones where it could be 6 times 1, and we're doing reverse FOIL, or it could be 2 times 3. Well, either of those is going to work, right? There's no way to combine 6 and 1 to get 2, and there's no way to combine 2 and 3 to get 2, so we're done. I was just hoping needlessly that there would be a further simplification. Okay, adding rational expressions. It's the same thing as, arithmetic, except now we have to be more careful with our x's and our y's, and we have to be cognizant that there's a domain limitation involved. All right, let's look at now a more complicated version of what we've just done. Something where we have to add and subtract and multiply and divide to get through it. This looks delightfully like one of the problems we had when we had numbers. People had problems with. So I don't know if this is going to be harder or easier because now we're doing it abstractly with variables. So in both the numerator and the denominator, we have sum or difference of fractions, so we need to put things over a common denominator in each case. So on the top, the common denominator is y. So we have x, but then this is going to be plus y. Here, the common denominator is x, so we're going to have x minus y. And now we're going to multiply by, we're dividing fractions, so we multiply by the reciprocal. And unfortunately, we don't have any nice terms that we're going to drop this time. So we could multiply it out. It's not necessary. Okay. Any questions about this? We're going to switch gears just a tiny bit here. We're going to look at something called rationalizing a denominator. Now, I think on Monday I said that I wasn't a big fan of rationalizing expressions like this. To me, they're perfectly okay. But sometimes you have a denominator that's kind of ugly and it has a radical, and you don't really want the radical in the denominator. So in particular, I'm going to look at this expression. And we want to get, we can't get rid of the radical, but we can get it out of the denominator. But to do that, we're going to have to look at this pattern, which, as I mentioned, is really useful. A squared minus b squared is a plus b times a minus b. Well, here's our a plus b. If I multiply this by 1 minus the square root of 2, that's my a minus b. Well, of course I have to always multiply by 1, so I don't change this. Now you can see what's going to happen here. On the bottom, I'm going to get 1 squared minus square root of 2 squared. On the top, I just have 1 minus square root of 2. But this is going to get rid of the radical in the denominator. This is 1 minus square root of 2 over 1 minus square root of 2 squared, which is 2. So I have 1 minus square root of 2 over minus 1, or to make it look a little nicer, let's multiply the top and bottom by minus 1. We'll get the square root of 2 minus 1 over 1, or just plain square root of 2 minus 1. So that's rationalizing the denominator. That would work equally well if we had a not a polynomial, but a expression with a variable in the denominator. So if, let's say I have 3 over square root of x minus 2, and I don't want this radical square root of x in the denominator, I can multiply it by square root of x plus 2, square root of x plus 2, so I have 3 square root of x plus 6 on top. So now I have, what? Square root of x squared, that's just x minus 4. There are times when you will want to do this, where this is necessary. Okay, I had more optimistic hopes for today that we would get a little further, but I think it was worth pausing to talk about the homework. So I'm going to stop here on this section 1.4, so I'll have to do this homework. Are there any questions with any of this right now? Okay. I don't like to waste your, pay good money to come here. We've got 10 more minutes, but I will remain here, and if you have questions, any of the problems you want to look at, come up. Otherwise, we yeah, everyone sign who's here, sign this. Did you put your name on it, sir?
Yeah, it's Bob.
Good.
Give me a pencil.
Thank you, that's what I wanted. Come on up.